right?
So we'll try out the program.
Right.
If we don't finish it by a lab, then can we have the Viva based on the concept and we'll finish the program and send it to the respective sir later?
Uh, yes, it's possible, but I want you to at least complete one or two components, right? So today's lab program is about a railway reservation system, right?
Yes, sir.
With the insertion of passenger details like seat number, passenger name, source, destination, and so on. So you have an insertion module, you have a deletion module, you have an update module, and finally you have a module for listing the details of the passenger based on seat number and so on. So you have four modules. So I would advise you to at least complete two modules by the end of the day and show it to the research scholars. So you need not worry about the time frame. Like for evaluation, we have two exams. So I will be conducting continuous assessment exams similar to our cycle test for theory course. So we'll have two exams which carries a weightage of 25% each. We'll have final semester examination, and we also have a component for mini project, right? So it's very difficult to continuously evaluate the student each and every week, uh, like based on your performance. So we'll have two examinations, two continuous evaluation examinations, one semester examination. In addition to it, we have a mini project based on which the student's performance will be evaluated, right?
Okay, sir.
So I
This is
Yes,
would
a
sir.
like,
theory course only, right, sir?
yeah, I want to make it like similar to theory course because as per NIT requirements, it's like continuous evaluation. Like 75
Yes.
percentage of marks in lab is for continuous evaluation. Again, students are not physically present here, and it's very difficult to evaluate on day-to-day basis. So what I feel is that we'll have a similar set of examinations. Like we'll have similar to CT, maybe next week, or we'll have one uh, examination for lab also, so that students will be evaluated based on the examination that is conducted. So you need not worry about the time frame. So, but I would like you to be there during the lab, complete at least two models, and show it to the research scholar.
Yes, sir, we'll do that.
Right, right. So I think I'm sharing a document. Is it visible? So find the minimal
Yes, sir, it's
cover.
visible.
Yes, sir. Yes, sir.
Right. So the last topic, the problems in normalization. The last topic is set of functional dependencies in a you are expected to find the minimal set of functional dependencies in a relation, right? Again, you are expected to remove some redundant attributes in a relation, right? So you can have a look into the example one. So find the minimal cover or irreducible set from the following functional dependencies, right? So you assume that there is a relation with attributes A, B, C, and D respectively, and the following functional dependencies holds good. A, B determines C, D, and similarly B, C determines D. Now you are going to remove redundant set of functional dependencies that is being present in this relation, right? So first we go for simplification, union simplification. AB determines CD is equivalent to AB determines C, AB determines D, and BC determines D, right? So once you perform union simplification, you are expected to remove redundant set of functional dependency, right? So how to remove redundant set of functional dependency is that you are going to find the closure of left hand side, right? So you are going to compute the closure of AB closure from the equations 2 and 3 by hiding 1, right? So if we get the right hand side of the 1 from the equations 2 and 3, then the equation 1 is said to be redundant, otherwise it's non-redundant, right? So you have simplified functional dependencies available. AB determines C, AB determines D, BC determines D. Now you are expected to find the closure of left hand side of equation 1. So AB closure, if AB closure determines C from equations 2 and 3, and by hiding equation 1, if AB closure determines C from the equations 2 and 3, we say that the functional dependency AB determines C is going to be redundant, otherwise it's non-redundant, right? So let us find AB closure from equations 2 and 3. So AB closure is going to be AB, ABD, and so AB closure does not determine C. So AB determines C is going to be non-redundant, right? Now we are going to check whether the equation 2, the functional dependency AB determines C is going to be redundant or not. So again, you are going to find the closure of LH, left hand side of AB closure from equation 1 and 3 by hiding the right hand side of equation 2. So here AB closure is going to be AB, AB closure is going to be ABC, right? AB determines C. So AB closure is ABC. And again, BC closure is going to be D. So AB closure determines D, right? So AB closure can determine D from equations 1 and 3, right? So AB determines D is going to be redundant and it can be eliminated, right? So this is how we reduce functional dependencies in a relation. We call it as canonical cover or minimal cover of functional dependencies, right? Similarly for equation 3, so you are expected to find BC closure. We need to check whether BC closure determines D from equations 1 and 2 by hiding the right hand side of equation 3, right? So BC closure is going to be BC alone, right? So BC closure is BC alone. So BC closure cannot determine D from equations 1 and 2. So the equation 3 is going to be non-redundant, right? So this is how you go for a removal of redundant set of functional dependencies. So is it possible to follow, right? In canonical cover, you are going to find the minimum set of functional dependencies, right? So initially you are going for union simplification. So union simplification, you have the functional dependencies like AB determines CD. So it can be rewritten as AB determines C, AB determines D, and the third equation is going to be BC determines D. So now you are going to check whether the functional dependency AB determines C is going to be redundant or non-redundant. So how do you find it? You are going to find AB closure from equations 2 and 3 by hiding the equation 1, and if it returns else it's non-redundant, right? So here we have tried with that, and the AB closure gives ABD. So AB closure does not gives you C. So the equation 1 is going to be non-redundant, right? Then we move on to the equation 2. We find AB closure from equations 1 and 3 by keeping by hiding the equation 2. So here AB closure is going to be AB determines C, ABC, BC determines D. So AB closure determines ABCD. So it means that AB closure determines D, the second equation from the equations 1 and 2 itself. Sorry, from the equations 1 and 3 itself. So the equation 2 or the functional dependency 2 is going to be redundant. So you can eliminate it. And the last thing is that BC determines D. So you need to check whether BC closure determines D from equations 1 and 2 by hiding equation 3. So BC closure is going to be only BC. So the equation 3 is again non-redundant, right? So after removal of redundant functional dependencies, we need to go for removal of extraneous attributes, right? So now you have two functional dependencies, AB determines C and BC determines D, right? So you have two functional dependencies available. Now you need to check whether an attribute can be removed or an attribute is redundant, right? So we are going to remove A from AB determines C and find B closure, right? So if the attribute A exists in the closure, then A is said to be redundant. So B closure is going to be only B. So the attribute A is going to be non-redundant. Similarly, we are going to remove the attribute B from the equation AB determines C and check whether A can determine C, right? So if A alone can determine C, then B is going to be redundant. However, if you remove B from AB determines C and find A closure is going to be A alone, right? So AB determines C is going to be non-redundant, right? And then we'll explore with the equation 4. So you are going to check whether the attribute B is going to be redundant. So you are going to remove B and find the C closure. So if C closure can determine D, right, then then B is going to be redundant, right? So remove B from BC determines D and find C closure. So if C closure can give B, it's non-redundant. And again remove C from BC determines D and find B closure. So if B closure can give C, then it's going to be non-redundant. So however, all the attributes are going to be like they are going to be important attributes. They are non-redundant attributes. So finally, the irreducible set will be AB determines C and BC determines D. Right. So this is how you find the canonical cover for a set of functional dependencies, and you check for whether the attribute is an extraneous attributes, whether it's an redundant attribute in a present in a relation. So can you follow this problem? So in this
Yes,
problem,
sir.
right? So in this problem, just we have checked whether a dependency is going to be redundant functional dependency or not, and then we have checked whether an attribute is an extraneous attribute or not, right? So I think you can have a piece of paper and pen. You can note it down so that I will give you the next problem. Next problem, or you can you solve the next problem directly? I think you can solve the next problem directly, right? So find the minimal cover or irreducible set from the following functional dependencies. So you have a set of functional dependencies like A, B, C, D determines E determines D, AC determines D, and A determines B. Right. Now you are going to check for redundancy in functional dependency. So what will you do? So initially you need to go for union simplification. However, in this case, no need for union simplification as all the functional dependencies are already simplified. Right. Now you are expected to remove redundant set of functional dependency. Right. So now you need to find A, B, C, D closure from equations 2, 3, and 4 by hiding the equation 1. Right. So ABCD closure from equation 2, 3, 4, you get only ABCD. right? So the equation 1 is not redundant. So the equation A, B, C, D determines E is non-redundant. Now you are going to check whether the equation 2 is going to be redundant or not. So you are going to find E closure from equations 1, 3, and 4 by hiding the equation 2. So E closure is going to be E,
E.
right? So again, you cannot determine D from other equations 1, 3, and 4. So equation 2 is again non-redundant, right? Again, third equation, you are going to find AC determines D from equations 1, 2, and 4
Non-redundant also.
by hiding equation 3, right? AC closure is again AC, right? So it's going to be AC closure can determine
ABC,
AC,
sir.
B, ABC. A determines B, so AC closure is going to be ACB. However, it does not give the equation. However, it does not give the element D. So AC determines D is going to be non-redundant functional dependency, and A determines B. You are going to find whether A can determine B from equations 1, 2, and 3 by hiding the equation 4. So A closure is going to be again A. So all the functional dependencies are going to be non-redundant. Now, finally, you are going to go for extraneous attributes, removal of extraneous attributes. So you are going to remove A from BCD, A from ABCD, and find the BCD closure. So if attribute A exists, then the A is said to be redundant. So what is BCD closure? So BCD closure is going to be
BCD.
BCD alone, right? So A is said to be non-redundant. So again, we are going to remove B here and find ACD closure. If we can get B, then we say that it is going to be redundant. So ACD closure is going to be
ABCD.
ABCD. So it looks like B is a redundant attribute. So you are going to reduce the left hand side as ACD determines E. So, so initially it was ABCD determines E. Now it's going to be ACD determines E. Now again you are going to find whether C is a redundant attribute or not. You are going to remove C from ACD and find AD closure. And if AD closure gives you C, then C is going to be redundant. So AD closure is going to be only ABD, right? So AD closure is going to be ADB, and C is non-redundant. And finally, you are going to remove D from ACD and find AC closure from equations 2, 3, and 4. So AC closure is going to be again ACDB, right? So ACDB, and it does not gives you E, right? So AC closure is going to be AC closure is going to be AC. Remove C from ACD and find A closure. Then I think A closure is going to be only AB. I think here AC. So D is redundant. So initially we compute a AC closure. AC closure is going to be ACDB. So D is also redundant. So the first equation ABCD determines E gets reduced into AC determines E. Hope you can follow this, right?
Yes, sir.
So
Yes, sir.
AC determines
Yes, sir.
E. Similarly, we are going to make it for the other equations, whether you need to check whether so E determines D. That is going to be it's not you cannot work on it. Similarly, A determines B also. You have a single left hand side and single right hand side, so you cannot reduce it and check whether it's an extraneous attribute. So you can work only with AC determines D. So you are going to remove A from AC determines C, AC determines D, and find C closure. If C closure gives you A, we say that attribute is an redundant attribute. So our C closure is going to be only C. So AC determines D is going to be, so A is non-redundant. Similarly, C is also non-redundant, right? So, so this is how we work with finding extraneous attributes and working with simplification of functional dependency, right? So I hope you can follow this class, right?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So I will share the document in the course materials. You can have a look into it. I think with this we complete all the problems in uh, the chapter working with normalization, right? So normalization for database design, you need to know about the different types of anomalies like insertion anomaly, deletion anomaly, update anomaly. So we also studied something called the closure property. We studied how to check whether the decomposition is going to be a lossy decomposition or a lossless decomposition. We checked how to check for whether the functional dependency is preserved in the decomposed relations, right? So whether it's a dependency preserving functional decomposition, whether the functional dependency is preserved in the decomposition or not. And then finally, in today's class, we have studied about canonical cover, where we have reduced the set of functional dependencies that are present in a relation, right? So you are going to have some minimal set of functional dependencies for a relation by reducing the redundant functional dependencies that are available in a relation. We also worked with how to remove some extraneous attributes that are present in a relation, right? So whenever there exists some extraneous attributes in a functional dependencies in a relation, that also we studied how to remove it. So we have studied with working with first normal form, second normal form, and third normal form. So we are left out only with fourth normal form and fifth normal form. So probably when we come back for the next class, we'll complete normal forms 4NF, 5NF, and we'll move on to unit 4, which is about working with transaction management. So any questions about today's class? Any clarifications needed?
No, sir.
Right.
No, sir.
So that's it. So thank you for your participation. So we'll meet during the lab class. So lab class, like you can have your own backend database. I have given MySQL, but I think it can be customized to any backend database. So we'll study how to work with, we'll explore working with Python and SQL in today's lab class. So thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.